Hello everyone. So in this video we will study the different concentration terms. So what are the different concentration terms to be used to express the concentration in solution? So all these are nothing but the different concentration terms, that is molarity, molality, normality, mole fraction, ppm, percentage mass and percentage volume. So we will study one by one. So what is molarity? It is also one of the concentration term. Then how can we define this molarity? Molarity of a solution can be defined as the number of moles of solvent. Number of moles of solute dissolved in 1 liter of solvent. That means by taking 1 liter of solvent, how many number of moles of solute has dissolved in 1 liter of solvent, that is expressed in terms of molarity, one of the concentration term. That is molarity can be defined as number of moles of solute dissolved in 1 liter of solvent, and which is the equation used to calculate the molarity of a solution. That is molarity of a solution is equal to number of moles of solute divided by volume of solvent in liters. So we are taking the solvent volume in terms of liters and the solute is in terms of number of moles. So number of moles of solute divided by volume of solvent in liter is the equation used to calculate the molarity of a solution. And then what is the unit of molarity? So molarity is expressed in terms of moles per liter or moles per dm cube. Dm cube is nothing but the liter or molar. So these are nothing but the units used to express the molarity of a solution, and molarity can be defined as the number of moles of solute dissolved in 1 liter of solvent, and the equation used to calculate the molarity of a solution is molarity is equal to number of moles of solute divided by volume of solvent in liters. Next, we will go through the molality. So the second concentration term is molality. So how can we define this molality? So molality can be defined as the number of moles of solute dissolved in 1 kg of solvent. So instead of 1 liter, we are going to take 1 kg of solvent. That means we are expressing the solvent in terms of mass, that is in terms of kg. So molality can be defined as the number of moles of solute dissolved in 1 kg of solvent. So molality can be defined as the number of moles of solute dissolved in 1 kg of solvent, and the equation used to calculate the molality of a solution is the number of moles of solute divided by mass of solvent in kg. So what is the unit of molarity? So how can we express the molarity of a solution, and what is the unit of molarity means? So the unit of molarity is moles per kg. So moles per kg is nothing but the unit of molarity, also called as molar. Molar is also one of the unit of molarity. So that is the second concentration term. Next, we will go through the third concentration term. It is called the normality. So what is normality? So normality can be defined as number of gram equivalent mass of solute dissolved in 1 liter of solvent. So in 1 liter of solvent, how many number of gram equivalent mass of solute has dissolved? So that is expressed in terms of normality. So normality can be defined as the number of gram equivalent mass of solute dissolved in 1 liter of solvent, and then which is an equation used to calculate the normality of a solution. So normality of a solution is equal to mass of solute dissolved in 1 liter divided by gram equivalent mass. So the equation used to calculate the normality of a solution is normality is equal to mass of the solute per liter. So how much of solute has dissolved in 1 liter divided by gram equivalent mass. And the unit of normality is nothing but gram equivalents per liter, or also called as normals. So this is nothing but the unit of the normality, the third concentration term. Next, we will go through another fourth concentration term. It is called the mole fraction. So how can we define mole fraction? So mole fraction of any component. So that means first we will take one of the solution. In this solution, there is a presence of solute and also solvent. Solute and solvent. So if we consider this solute, this is one of the component. And solvent is also another component. Okay. So separately we are taking solute as one of the component and solvent is also one of the other component. So if we want to calculate the mole fraction of any component present in the solution, we are going to use one of the equation, mole fraction. Mole fraction of component. So it may be either solute or solvent. Mole fraction of any component can be defined as number of moles of that component. Number of moles of that component divided by total number of moles of solution. So if N1 be the number of moles of solvent and N2 be the number of moles of solute, so the first prefix, the suffix, the 1 represents for solvent and the number 2 represents solute. So N1 is nothing but the number of moles of solvent and N2 is the number of moles of solute. The sum of these two, this N1 plus N2, can be taken as total number of moles of solution. So in that total number of moles of solution, so what is the fraction of number of moles of individual component is present? That is to be determined using this equation. So mole fraction of any component, it may be either solute or solvent, can be taken as the ratio of number of moles of that component. If it is solute, you have to take the number of moles of the solute component divided by total number of moles of solution. So if we take it is solvent, the component is solvent, mole fraction of solvent is equal to number of moles of the solvent divided by total number of moles of solution. So by using this equation, we are going to calculate the mole fraction of any component present in the solution. Next, what is ppm? So ppm means parts per million. So what is the value of million? ppm means parts per million. Parts per million. So what is the value of million? Million means 10 power 6. 10 power 6 can be taken as million. So we are having one of the equation to calculate the value of ppm. So ppm is to be calculated using the equation mass of solute divided by mass of solvent or solution, mass of solution into 10 power 6. That means in 10 power 6 grams of solution, what is the mass of solute present? That is to be expressed in terms of ppm. That means how can we define ppm? So ppm can be defined as the number of parts by mass of solute dissolved in 10 power 6 part by mass of solution. So how can we define ppm? ppm can be defined as the number of parts by mass of solute dissolved in 10 power 6 part by mass of solution. So that is nothing but the ppm, and the unit of this ppm is nothing but only ppm, parts per million. Okay, so then we will go through another concentration term. It is called percentage mass. So percentage mass. So we are having in a solution there is the presence of solute and solvent. So in this solution, the combination of solute and solvent, if M1 is the M2 is the mass of solute and M1 be the mass of the solvent, then we are going to take the sum of these two as M1 plus M2. So M2 is the mass of solute and M1 be the mass of solvent, then the total mass of solution can be taken as M1 plus M2. And how can we calculate the percentage mass of individual components? So it may be either solute or solvent. We are going to calculate the percentage mass of solute or also percentage mass of solvent. So percentage mass of any component, percentage mass of any component can be defined as mass of that component, divided by total mass of solution, into, so we are calculating the percentage of that component, percentage mass of that component, so we are multiplying from 100. So this equation used to calculate the percentage mass of the individual component. So component will be either solute or solvent. So we can calculate the percentage mass of any component by using this equation. That is mass of that component divided by total mass of solution into 100. So that is one of the concentration term. And finally we will go through the percentage volume. So to find out this percentage volume, that is the concentration of any solution in terms of percentage volume. So instead of mass, we have to take the volume. So percentage volume. Percentage volume of any component is equal to volume of that component divided by total volume of solution into 100. That means we are preparing one of the solution by taking the solute and solvent. If V1 be the volume of solvent and V2 be the volume of solution, solute, so the sum of these two can be taken as total volume of solution. V1 plus V2 can be taken as total volume of solution. So we know that the V1 is the volume of solvent and V2 be the volume of solute. The sum of V1 plus V2 can be taken as total volume of solution. So in the total volume of solution, so per 100 of the total volume of solution, what is the volume of individual component is present? That is percentage volume of any component can be taken as volume of that component to the total volume of solution into 100. So these are nothing but the different concentration terms which are used to express the concentration of any solution. So among these concentration terms, which concentration term depends on temperature? That is to be identified. So temperature dependent concentration terms. So here molarity is determined by taking the solvent in terms of volume. As the temperature increases, the volume of solvent and the solution gets changed. Hence, this is the one of the concentration term which depends on temperature. And then the normality. So normality is also one of the concentration term which depends on temperature, because in this normality determination we are going to use the solvent in terms of volume. So then we can say normality is one of the concentration term which depends on temperature. and then we are going to take the percentage volume. So in this percentage volume also we are going to take the solvent or the solute in terms of volume. So that by the variation of temperature the volume of the solvent or the solid gets changed. Hence this is also one of the concentration term which depends on temperature. Then temperature dependent concentration terms are nothing but the molarity, normality and also the percentage volume. So if we go to the temperature independent concentration terms, molality is one of the temperature independent concentration term because this molality is expressed in terms of number of moles per kg. That means we are expressing the solvent in terms of kg. Hence, this is the one of the concentration term which is independent of temperature. So, whatever the concentration term which depends upon the volume of solvent, that is only depends on temperature. So, this is one of the concentration term which is independent of temperature. Then the mole fraction also, then ppm and also percentage also. So, in all these concentration terms, the solvent is expressed in terms of mass. Hence, all those are nothing but the concentration terms which are independent of temperature. And in these three, we are going to express the concentration of solution in which the solvent is in terms of the volume. So, because of that reason, molarity, normality and also percentage volume are depends on temperature.